welcome back. We're looking at lesson 16 today, interpreting inequalities. So let's go ahead and jump right in. We're also looking at lesson 17, which is modeling with inequalities. So once again, there'll be only one video keyword, but you will have 2 sets of practice problems. All right. So for lesson 16, we want to solve some inequalities. For each inequality, find the value or values of x that make it true. So we have 8x plus 21 is less than or equal to 56. So the first thing we need to do is we can think about this as just a regular equation. We need to subtract the 21 because our goal is to get the x by itself. So now we have 8x is less than or equal to 56 minus 21, which is going to give us a 35. And then we're going to take, brain. And then we divide that by 8. So x is less than or equal to 35 divided by 8, which is 4.375. So our values have to be less than 4.375. So one possible solution would be 4. Okay? We could also have 0, we could have negative 10, we could have negative 100. Those are all possibilities for solutions to it, but this is the key thing. It has to be less than or equal to 4.375. Okay? All right, the next one, we have 56 is less than 7 times 7 minus x. So we're going to divide by 7 to start. So 56 divided by 7 is 8 is less than 7 minus x. So then I'm going to subtract the 7. So 8 minus 7 is 1. 1 is less than negative x. Now, we have a negative on our x. So I'm going to divide by negative 1, divide by negative 1. That'll cancel. So we're left with negative 1 and x. But when we divide or multiply by a negative number, when we have inequalities, it flips the inequality symbol. So now, instead of 1 being less than negative x, it's negative 1 is greater than x. So, and sometimes it helps writing out what that looks like in left to right, so then it's not as confusing. Okay? That will always be the case. Anytime you take and multiply or divide by a negative, it's going to switch your inequality symbol. All right, club activities matching. Choose the inequality that best matches each given situation. No, we do not have to solve these. We just have to figure out which one best represents the situation. So the garden club is planting fruit trees in their school's garden. There's one large tree that needs 5 pounds of fertilizer. The rest are newly planted trees that need a half pound fertilizer each. So what is our inequality? So we know that there's one tree that needs 5 pounds. So that means we should be adding 5 pounds in one of these. So it's not going to be this one because we're not adding 5. We're not adding 5. So now it's between these two. The rest are newly planted trees that need a half pound fertilizer each. So if it's telling you something is a value for each, that means we're going to be multiplying by it, which means it's going to be attached to our variable, which means 1/2 x plus 5 is less than or equal to 25. All right, for number 2, the chemistry club is experimenting with different mixtures of water with a certain chemical, sodium polyacrylate, to make a fake snow. To make each mixture, the students start with some amount of water and then add 1/7 of that amount of the chemical and then 9 more grams of the chemical. The chemical is expensive, so there can't be more than a certain number of grams of the chemical in any one mixture. So for this one, it's telling us that we're adding 1/7 of the amount of the chemical. So 1/7 should be attached to our variable. And then we're adding 9 more grams of the chemical. So if we look, we've got 1/7 x plus 9 is less than or equal to 26.25. So it's less than a certain amount because it says it can't be more. So that looks to be our accurate one because it's dealing with the 1/7 and adding the 9. That's the only one that looks like that. For number 3, the hiking club is on a hike down a cliff. They began at an elevation of 12 feet and descend at a rate of 3 feet per minute. So we're starting at 12 and then we're descending 3 feet per minute. So the per minute tells us that that's going to be our variable. So we need to look for one that has a negative 3x because when we're descending, that's going to be a negative value. So it doesn't have a negative 3x, has 3x, but it's not negative, has a negative 3x, does not have a negative 3x. So there is our answer. It is C. For number 4, the science club is researching boiling points. They learn that at high altitude, water boils at lower temperatures. At sea level, water boils at 212 degrees Fahrenheit. With each increase of 500 feet in elevation, the boiling point of water is lowered by about 1 degree Fahrenheit. So we are taking and looking at an increase of 500 feet in elevation, and the boiling point in water is lowered by 1 degree. So it's a ratio of 1/500 because we're going down the 500, and it's a negative because we're going down and we're lowering. And we have the 212, so that's our starting value. So it should be our constant, and then looking for the one with our ratio. So it is A. So these are looking at different contexts and creating inequalities for them. So your keyword for these 2 lessons are context. Context. All right, skipping over to lesson 17, model with inequalities. Possible values. A stage manager of the school musical is trying to figure out how many sandwiches he can order with the $83 he collected from the cast and crew. Sandwiches cost $5.99 each, so he lets X represent the number of sandwiches he will order and writes $5.99 X is less than or equal to 83. He solves this to 2 decimal places, getting X is less than or equal to 13.86. Which of these are valid statements about this situation? So he can call the sandwich shop and order exactly 13.86 sandwiches. Can we have 0.86 of a sandwich? No. He can round up and order 14 sandwiches. Does he have enough to do that? Nope. He can order 12 sandwiches. Yeah, he definitely could. He's got enough for that. He can order 9.5 sandwiches. Once again, he's got enough for that. He can order 2 sandwiches. That is also a possibility. He can order -4 sandwiches. Definitely not. We can't have a negative number of sandwiches. We have to think about these in terms of real life context. So remember, context is your keyword. So looking at this, X is less than or equal to 13.86. So as long as our value is less than 13.86, it's a possible sandwich number that he can get. But obviously, in the sense of mathematics, we can keep going with that and go all the way to -100. But based on this context, that's not something we can do. We have to take and think about it. Can we have negative number of sandwiches? No, we can't. So we have to think about it in terms of the context when we're looking at answers and possibilities there, okay? All right. A mover is loading an elevator with many identical 48-pound boxes. The mover weighs 185 pounds. The elevator can carry at most 2,000 pounds. Write an inequality that says that the mover will not overload the elevator on a particular ride. Check, and it well, obviously won't check with your partner. So the boxes are all 48 pounds. So 48x plus, he's going to be in the elevator with them. So 185 has to be less than or equal to 2,000 because that's the most amount of weight that the elevator can carry at any one given moment. So there's our inequality. Now we want to take and solve to explain what this means, or to find out what the solution means. So we would subtract the 185. So when we subtract the 185, 2,000 minus 185 gives us 48x is less than or equal to 1815. We divide by 48, divide by 48. X is less than or equal to 37.8125. So what this means in terms of our solution, he can take and load 37 boxes onto the elevator, but he cannot load more than 37 boxes or it's going to be too much. Now, obviously he can't load a portion of a box, so that's why we say just the 37. If we were to graph this on the number line, here would be our 37, oops, 0. That's the wrong thing. 37. And everything lowered to 0. And it can only be whole numbers because we can't have portions of boxes. If the mover asked how many boxes can I load on this elevator at a time, what would we tell them? Well, we'd say 37 because we have to deal with whole numbers. We can't take and deal with portions of boxes. He's not going to take and empty half the stuff out of a box and then load it on and have half a box. That's not something he can do. So we have to look at it in terms of whole numbers. So the maximum he could do is 37 boxes. Okay, so these are all about context and understanding what it means in terms of the context and how that affects your answer, because sometimes it does. It affects what our answer can be because we can't say, yeah, you can load 37.8125 boxes on there. That doesn't work. So you have to think about it in terms of the context. Can we have a portion of box? No, so it's 37 boxes. All right, remember your keyword for this lesson is context, context. If you have any questions, feel free to ask. Have a great day, guys. Thanks.